Hello, I am back again because I don't know. I solved a problem, which is this one from Vietnam. A function which is positive on this closed interval is given. F of 0 is given to be 1, and for every number within this interval, this relation holds. We are supposed to answer this. We are supposed to calculate this integral. Yes? Okay. And now I did it in two different ways, but when I was very happy that I could do it in two different ways, but when I was going home, I realized that might be there is an alternative way which might be faster for the purpose of just finding the answer. Because I wanted to find first, when I wanted to do it before doing the video, I wanted to find f of x. I tried to change the transform, to do the transformation x to 2 minus x, and then of course this becomes this one, this becomes that one, and this expression is invariant under this transformation, meaning that if you replace x with 2 minus x, this function goes back to itself. It's a very simple algebra. You can convince yourself of that immediately. So then I realized, okay, if I change x to 2 minus x, this will go back to itself, so it will not give me any new piece of information so that I can use it and find f of x. But then I was going home, I realized, okay, what type of function should it be there? I'm not completely sure, but it seems that this function is an exponential function. And because the exponent is a quadratic expression, it is reasonable. I don't have proof for it, at least now, but it is reasonable to think that the function f of x is of this form, e to the power of a quadratic polynomial. If this is possible to assume that, then I can find it easily. How? By just putting it back into the function. So f of x is e to the power of ax squared plus bx plus c multiplied by e to the power of the same thing, but 2 minus x instead of x. So it becomes a2 minus x to the power of 2 plus b times 2 minus x plus c. And then it is supposed to be identical to 2e to the power of 2x squared minus 4x. Then, of course, the exponent here plus the exponent here should match the exponent here because these are powers with the same bases. And I calculate it simply. So this becomes ax squared plus bx plus c, and then plus, I open this up. 4 times a, 2 times the first one times the second one times a, the second one squared times a, and then I have 2b minus bx plus c. Yes? This is supposed to be equal to this exponent, but let me combine them. This one and that one is 2ax squared plus this bx and this minus bx are gone. I will have a minus 4ax there. So I consider that one. And then what do I have? I have a 4a from here. I have a c and 2b. So 2b plus 2c. This is supposed to be equal to this exponent, identically equal to that exponent. So this means that the coefficient of x squared here should match with the coefficient of x squared there. So it means a is 1. And if a is 1, this is automatically minus 4x, which matches. But this constant term should be 0 because there is no constant term there. A is 1, I put it here. So 4 plus 2b plus 2c equals to 0. So this, for example, if I move 4 to the other side and divide by 2, b plus c is what? Is minus 2. Okay, so from here, what can I get? I can get c is minus b minus 2. And then it means that my function f of x, which was this function, a is 1, so it becomes e to the power of x squared. B is b, but c is minus b minus 2. Yes, so I put it there. Minus b minus 2. But I have another condition up there. You see, it was given that f of 0 is 1. Okay, and I use that to fine-tune this leftover parameter. So I would say that f of 0 is supposed to be 1. What does it mean? It means that if you replace x with 0, the answer should be 1. But this means that this exponent is 0, so this means b is minus 2. If b is minus 2, I put it there, f of x simply becomes e to the power of x squared minus 2x plus 2 minus, that's it. So that is my function then. Okay, which was very easy now. You can see it should be possible for us to guess. But guessing is not my style, so I want to really find a way. So this is based on the fact that this function is exponential function of this type, then it has to be this function. And I think the integral will be very simple. Okay? So this becomes integral from 0 to 2 x cubed minus 3x squared, and then f prime of x, which is the derivative of this combination 2x minus 2 times the function itself divided by the function which is the same function, and then dx. And now what happens, this is gone, and I'm getting a very simple integral. Okay? So I don't know. So integral from 0 to 2, I multiply that, it becomes 2x to the power of 4 minus 2x cubed and minus 6x cubed, so it is minus 8x cubed, and then plus 6x squared dx. And then I calculate this one, so it becomes 2/5 x to the power of 5. This becomes minus 2x to the power of 4 plus 2x to the power of 3. I have to run it from 0 to 2. So if I put 2 there, 32 64 over 5, and then I put 16, 32, and then if I put it here, it becomes 16. Yes, and that is, I think, the correct answer. 64 over 5. This becomes minus what? Minus 16, and then this becomes minus 16 over 5. And that was exactly the answer that I got it from this very, very long method. To be honest, I also like this method. First of all, it is much faster. The only thing is this assumption. I haven't still convinced myself that I can make this assumption, but it seems very reasonable. Okay? So, this is also one way. I couldn't wait not to share it with you immediately, so I came back to the office and I made this video. So now I will upload this. It is up to you. I will, of course, think about it more. You can also leave comments. I would appreciate that. The only flaw in this calculation is just the fact that can I really assume based on this that the function f of x is of this form? Because if I can, then everything goes very well. So this is the correct solution. So I will also think myself during the weekend to see how can I do. If I come up with a good idea, I will leave a comment for you there as well. You can also do a favor if you can find a way to see why this is the only plausible way of thinking about the function. I would be very thankful. Okay, this time really nice weekend. Thank you very much. Bye.